Good afternoon. My name is Owen McDonough, Senior Science Advisor to the Assistant Administrator for EPA's Office of Water. I want to thank you for your time and your interest in today's webcast on the final Navigable Waters Protection Rule, which revises the regulations defining waters of the United States and the scope of federal jurisdiction under the Clean Water Act. On June 22nd, the Navigable Waters Protection Rule became effective in all states and jurisdictions except for the state of Colorado, due to a court-issued stay in that state. The EPA and the Department of the Army are hosting this series of webcasts to highlight key elements of the final rule and how it will be implemented. Today's session is the fourth in the series and discusses the definition of adjacent wetlands and jurisdictional lakes, ponds, and impoundments, as well as implementation considerations. This webcast is being recorded and will be hosted on the agency's websites for later access. The final rule reflects legal precedent set by key Supreme Court cases, as well as robust public outreach and engagement, including significant pre-proposal input and over 620,000 comments received on the proposed rule. The agencies have streamlined the definition of WOTUS to include 4 clear categories of jurisdictional waters, to provide specific exclusions for many water features that traditionally have not been federally regulated, and to define terms in the regulatory text that have never been defined before. I'm pleased to note that the EPA has worked side by side with our partners at the Department of the Army throughout the two-step rulemaking process. Matt Wilson, Regulatory Program Manager for the U.S. Army Corps of Engineers, is also on the line to answer questions following the presentation. I will now turn the meeting over to Ms. Stacey Jensen, Assistant for Regulatory and Tribal Affairs for Army Civil Works, and Ms. Mindy Eisenberg, Associate Director of the Oceans, Wetlands, and Communities Division at EPA, to walk through the provisions of the final rule relating to lakes, ponds, and impoundments, as well as adjacent wetlands. Stacey?
Thank you, Owen. You should be connected to this webinar through your computer. At this time, you should see a slide that is titled Webinar Logistics. You can listen to this webinar's audio through your computer or by dialing into the call-in number. The call-in number is 650-479-3208, and the access code is 127-097-3932. Please note that due to the large number of participants, questions will only be accepted in writing through the platform, so you do not need to call in. Once you are connected to the audio, if you hear an echo, please turn off your computer speakers. All participants have been automatically muted to avoid any echo and sound issues. If you're not able to connect to the WebEx platform and therefore cannot view the presentations, you can still listen in through the phone and you'll be able to hear the presentations from our speakers. If you have any technical difficulties, please send an email to epa@horsley-witten.com. Again, that is epa@HORSLEYWITTEN.com. This webinar is being recorded. If you would like to view the presentations larger than what is shown in the webinar screen box, please select View from the menu in the upper left-hand corner, as shown by the red circle on the slide. Once the menu drops down, select Full Screen. Once you are in the full screen mode, you can zoom in and out of the view by clicking on the plus or minus buttons on the left-hand side of the gray bar. To return back to the previous normal screen mode, use the icon in the upper right-hand corner of the screen. You will need to do this in order to ask questions through the question box. We welcome questions from our participants. In order to ask a question, please use the question box as opposed to the chat box. If the Q&A box is not already located at the right of your screen, please navigate to the icon indicated at the bottom of your screen and select the icon with the 3 dots on it. Click on this icon and select Q&A. Once the Q&A box has appeared on your screen, type your question in the message box after clicking on the arrow to the left of Q&A in the box. Make sure that you ask all panelists. This setting will ensure that all speakers see your question. Hit send when you're ready to submit the question. Note that your submitted question will only be seen by the panelists. Your question will be read out loud at the end of the presentation, and the speakers will answer. Depending on time, not all questions may be answered. This week's webinar is focused on the lakes, ponds, and impoundments of jurisdictional waters category, as well as the adjacent wetlands category. Next week is our final webinar in this series, and we will provide an in-depth look at waters and features that are excluded from the definition of waters of the United States under the Navigable Waters Protection Rule, as well as provide an overview of the Corps' jurisdictional determination process and the agency's aquatic resource mapping efforts. We will also cover other select topics that have been informed by the questions we received during this webinar series. For today's webinar, we are going to focus on the key components of the lakes, ponds, and impoundments of jurisdictional waters category and the adjacent wetlands category under the Navigable Waters Protection Rule. We will cover different criteria that water features must meet to be considered jurisdictional under these categories. We will also highlight some of the tools and resources that can be used to help determine when a lake, pond, impoundment of a jurisdictional water, or wetland is jurisdictional. Then we will provide time for questions through the Q&A box. For the first part of this presentation, we will focus on paragraph A3 waters, the lakes, ponds, and impoundments of jurisdictional waters. Although regional naming conventions may vary, the agencies concluded that the terms lake and pond are well understood, and that additional regulatory definitions beyond what is included in the final rule were not necessary. Rather than defining lakes and ponds based on their geomorphology or artificial or natural status, the agencies have instead defined surface water characteristics and conditions in paragraph C6 for purposes of establishing jurisdiction over lakes and ponds. In paragraph C6, the rule describes lakes, ponds, and impoundments of jurisdictional waters as standing bodies of open water. Some lakes and ponds are naturally formed by events, such as fluvial, glacial, tectonic, and volcanic activity. Lakes, ponds, and impoundments can be man-made features that are constructed for a variety of purposes, including industrial and agricultural uses, power generation, domestic water supply, or for aesthetic or recreational purposes. Lakes, ponds, and impoundments can also be modified by human activities that change their surface elevation, depth, and size. Before we discuss the conditions for when a lake, pond, or impoundment of a jurisdictional water is a water of the U.S., I want to note that in paragraph B8, the Navigable Waters Protection Rule excludes certain artificial lakes and ponds, including water storage reservoirs and farm, irrigation, stock watering, and log cleaning ponds, constructed or excavated in upland or in non-jurisdictional waters, so long as those artificial lakes and ponds are not impoundments of jurisdictional waters that meet the conditions of paragraph C6. The artificial lakes and ponds exclusion will be discussed in more detail in the upcoming exclusions webinar, as well as other exclusions that may implicate lakes, ponds, and impoundments. Lakes, ponds, and impoundments of jurisdictional waters are jurisdictional if they meet one of the following criteria. First, they can be jurisdictional by meeting the definition of an A1 water. As a reminder, A1 waters are the traditional navigable waters and the territorial seas. Lakes, ponds, and impoundments of jurisdictional waters are jurisdictional as A3 waters if they contribute surface water flow to an A1 water in a typical year, either directly or indirectly through one or more A2 through A4 waters, or through channelized non-jurisdictional features. They can also be jurisdictional as A3 waters if they are inundated by flooding from a paragraph A1 through 3 water in a typical year. We will discuss these paragraph A3 criteria in more detail on the following slides. It is important to note that impoundments must be impoundments of jurisdictional waters to meet the A3 criteria that I just mentioned. In other words, an impoundment needs to have impounded a jurisdictional water. Then it can be assessed to determine if it is an A3 water under the Navigable Waters Protection Rule. Under the final rule, lakes, ponds, and impoundments of jurisdictional waters are only jurisdictional as A3 waters if they meet the conditions of paragraph C6, including contributing surface water flow to a downstream jurisdictional water in a typical year. As a reminder, typical year means when precipitation and other climatic variables are within the normal periodic range, seasonally or annually, for the geographic area of the applicable aquatic resource based on a rolling 30-year period. Typical year is a term that is used to ensure that the hydrologic flows and surface water connections necessary to establish jurisdiction under the final rule are characterized based on normal, i.e. typical, climatic conditions. The recorded webinar on typical year will be posted to the Navigable Waters Protection Rule website in the coming weeks. In cases where a lake, pond, or impoundment does not contribute surface water flow to a downstream jurisdictional water in a typical year, the feature would not be jurisdictional under that criterion. For instance, an artificial feature such as a dike or berm could prevent a lake or pond from releasing surface water downstream in a typical year. Similarly, a dam could be constructed such that it prevents an impounded water from releasing surface water downstream in a typical year. Such lakes, ponds, and impoundments would not be jurisdictional on the basis of contributing surface water to a downstream jurisdictional water in a typical year. Contributions of surface water flow in a typical year may occur through a channelized, non-jurisdictional surface water feature, through a culvert, dike, spillway, or similar artificial feature, or through a debris pile, boulder field, or similar natural feature. The rule does not distinguish between natural and artificially manipulated surface water flow that connects a lake, pond, or impoundment of a jurisdictional water to another water of the U.S. in a typical year. Surface water contribution in a typical year can occur through pumps, floodgates, reservoir releases, or other mechanisms. Furthermore, if an artificial feature, such as a dike or dam, causes a channelized downstream perennial or intermittent feature to become ephemeral, that channelized ephemeral feature would be excluded under paragraph B3, but would not sever jurisdiction of upstream waters as long as it conveys surface water flow to a downstream jurisdictional water in a typical year. Conversely, lakes, ponds, and impoundments of jurisdictional waters upstream of excluded features are not jurisdictional if the excluded feature isn't channelized, for example, if it's diffuse stormwater runoff or directional sheet flow. The excluded feature does not convey surface water flow to an A1 water, for example, if it's connected through groundwater, or the excluded feature doesn't convey surface water flow to an A1 water in a typical year. For example, if flow is only conveyed in the 100-year storm event. In addition to contributing surface water flow to an A1 water in a typical year, lakes, ponds, and impoundments of jurisdictional waters are jurisdictional under paragraph A3 if they are inundated by flooding from a paragraph A1 through 3 water in a typical year. This may apply, for example, with certain oxbow lakes that are located in a former channel of a meandering river. Inundation by flooding from an A1 through 3 water must occur in a typical year. Inundation can occur as a result of seasonal or permanent flooding, for example, so long as inundation occurs in a typical year and has as its source an A1 through 3 water. Impoundments of wetlands may also be jurisdictional if they meet certain conditions. A wetland is considered an impoundment of a jurisdictional water if it met the final rule's definition of adjacent wetland at the time it was impounded. If the impoundment still meets the definition of adjacent wetland, then it's jurisdictional as an A4 water. If the impoundment is now a standing body of open water and meets the conditions of an A3 water, then it is jurisdictional as an A3 water. Now that we've discussed lakes, ponds, and impoundments of jurisdictional waters under the rule, we will move on to the next part of the presentation, which focuses on adjacent wetlands. The agencies have not modified their long-standing regulatory definition of wetlands. Prior to determining whether a wetland meets any of the conditions of adjacency under the final rule, it must first meet the regulatory definition of wetlands, meaning it has the appropriate hydrology, vegetation, and soils. Note that the regulatory definition of wetlands is different than the coordinated definition of wetlands utilized by the U.S. Fish and Wildlife Service and the National Wetlands Inventory, which is a broader definition of the term. The agencies will continue to use existing resources, methods, and practices to verify the presence of wetlands and to delineate wetland boundaries. For example, the agencies will continue to use the Corps' 1987 Wetlands Delineation Manual, as well as any other applicable resources for verifying the presence of a wetland and to delineate wetland boundaries. The delineated boundary of a wetland remains constant, even though certain wetland indicators may not be present year-round due to normal seasonal or annual variability. And a complex of wetlands with a continuous physical surface connection is delineated as one wetland. The rule defines wetlands as areas that are inundated or saturated by surface or groundwater at a frequency and duration sufficient to support, and that under normal circumstances do support, a prevalence of vegetation, typically adapted for life in saturated soil conditions. Wetlands generally include swamps, marshes, bogs, and similar areas. In contrast, the rule defines upland as any land area that under normal circumstances does not satisfy all three wetland factors, i.e. hydrology, hydrophytic vegetation, hydric soils, identified in the definition of wetlands, and does not lie below the ordinary high water mark or the high tide line of a jurisdictional water. If a feature meets the definition of a wetland under the Navigable Waters Protection Rule, that wetland must meet at least one of the following criteria to be jurisdictional as an adjacent wetland under paragraph A4. First, it abuts, meaning to touch at least one point or side of an A1 through 3 water, or it is inundated by flooding from an A1 through 3 water in a typical year, or it's physically separated from an A1 through 3 water only by a natural berm, bank, dune, or similar natural feature, or 4, it is physically separated from an A1 through 3 water only by an artificial dike, barrier, or similar artificial structure, so long as that structure allows for a direct hydrologic surface connection between the wetlands and the jurisdictional water in a typical year, such as through a culvert, flood or tide gate, pump, or similar artificial feature. And we will discuss each of these 4 criteria in more detail on the following slides. In last week's webinar, we discussed jurisdictional ditches and noted that a ditch constructed in an adjacent wetland and that develops wetland characteristics can be jurisdictional as a paragraph A4 water. However, we will not discuss ditches in further detail in this week's webinar. One of the ways a wetland can meet the definition of adjacent wetland is by abutting an A1 through 3 water. Abutting occurs when the wetland's delineated boundary touches at least one point or side of the delineated boundary of the A1 through 3 water. Wetlands that abut other jurisdictional waters are adjacent under the final rule, absent evidence of a hydrologic surface connection occurring between the two, as not all abutting wetlands display surface water as the wetland hydrology factor, but rather may have saturated soils, a high water table, or other indicators of hydrology. The wetlands need not abut for a specific duration in order to be considered abutting. For example, wetlands that abut a tributary only during the wet or rainy season remain adjacent under this final rule. Similarly, if a wetland abuts an intermittent tributary, it remains abutting even when water is not present in the tributary. Wetlands abutting an ephemeral stream or other non-jurisdictional feature are non-jurisdictional, even if the non-jurisdictional feature maintains jurisdiction between upstream and downstream waters. Another way that a wetland can meet the definition of adjacent wetland is if the wetland is inundated by flooding from an A1 through 3 water in a typical year. Inundation can occur as a result of seasonal or permanent flooding, for example, so long as inundation from an A1 through 3 water occurs in a typical year. An inundation need only occur at least once in a typical year to establish adjacency for wetlands, with no particular requirement for the volume or duration of inundation. However, a wetland flooded by a jurisdictional water, on average, once every 100 years, and not meeting any of the other adjacency criteria would not satisfy the rule's adjacent wetlands definition. Inundation sufficient to establish adjacency occurs only in one direction, from the A1 through 3 water to the wetland, which provides a direct hydrologic surface connection from a jurisdictional water to an adjacent wetland. A wetland can also meet the definition of adjacent wetlands if it is physically separated from a paragraph A1 through 3 water only by a natural berm, bank, dune, or similar natural feature. Natural berms and banks are indicators of a regular surface water connection between the jurisdictional waters and the wetlands being inseparably bound up with the jurisdictional waters. While natural barriers may at times occur within a floodplain, the existence of a floodplain generally and other land masses similar to a floodplain, such as riparian areas or fluvial terraces, are not sufficient to indicate a direct hydrological surface connection. While a wetland perched above an incised channel may be adjacent, wetlands separated from jurisdictional waters by cliffs, bluffs, or canyon walls are not adjacent on the basis of being separated from a jurisdictional water only by a natural barrier, because such features prohibit regular surface water communication between jurisdictional waters and such wetlands. Finally, a wetland can meet the definition of adjacent wetlands if it is physically separated from an A1 through 3 water only by an artificial dike, barrier, or similar artificial structure, so long as that structure allows for a direct hydrologic surface connection between the wetlands and the A1 through 3 water in a typical year, such as through a culvert, flood or tide gate, pump, or similar artificial feature. A culvert, flood or tide gate, pump, or similar structure that allows for a direct hydrologic surface connection between a wetland and a jurisdictional water at least once in a typical year satisfies the definition of adjacent wetlands, even if flow is not present at the time of observation. The structure must allow for a direct hydrologic surface connection to occur at least once in a typical year, and there is no specific requirement for the direction, duration, or volume of flow. Unlike the inundation by flooding criterion, the artificial structure could allow for the surface water connection to occur from the A1 through 3 water to the wetland, from the wetland to the A1 through 3 water, or in both directions. If a wetland meets the definition of adjacent wetlands, the rule provides that an adjacent wetland is jurisdictional in its entirety when a road or similar artificial structure divides the wetland, as long as the structure allows for a direct hydrologic surface connection through or over that structure in a typical year. The structure must allow for a direct hydrologic surface connection to occur at least once in a typical year, and there is no specific requirement for the direction, duration, or volume of flow. A direct hydrologic surface connection can occur through a culvert or similar feature. And now I will turn the presentation over to my colleague, Ms. Mindy Eisenberg of EPA.
Thank you, Stacey. Now that we've discussed lakes, ponds, and impoundments of jurisdictional waters and adjacent wetlands, we will cover a non-exhaustive list of tools and resources that could be used to help determine the jurisdictional status of these features. We've discussed some of these tools in the context of tributaries, but they also have applications for identifying lakes, ponds, impoundments, and wetlands, determining if inundation by flooding from jurisdictional waters occurs in a typical year, assessing other wetland adjacency criteria, and determining contributions of surface water flow to downstream jurisdictional waters. Tools and resources that may be used include point-in-time data sources, which are data sources that represent the flow conditions at a specific location on a specific date, such as an aerial photograph or data sheets collected during a site visit. When using point-in-time data sources and discrete observations of flow to inform a determination of inundation by flooding or direct hydrologic surface connections, it will be necessary to conduct a typical year assessment for those observations to evaluate whether the conditions observed in a point-in-time data source represent those found in a typical year. The antecedent precipitation tool, as discussed in the previous webinar on typical year, is one tool that may be used to help determine whether point-in-time observations are representative of normal conditions. Other tools and resources include LIDAR and digital elevation model data, USGS topographic maps, the NHD, NWI, soil surveys, both current and historic, stream gauge data, and physical indicators, among others. It is important to note that this list is not exhaustive of all the resources out there that may help with determining jurisdiction of lakes, ponds, impoundments, and wetlands, but the list does include tools and resources that we expect may be used commonly. These tools can assist in making a jurisdictional determination based on the weight of evidence from all available data. On-site field observations are an ideal method for identifying wetlands, lakes, ponds, and impoundments of interest, as well as nearby surface water features. Identifying the contribution of surface water flow from lakes, ponds, and impoundments to downstream jurisdictional waters, identifying that a wetland, lake, pond, or impoundment is inundated by flooding from a jurisdictional water in a typical year, and identifying natural barriers and artificial structures that could be used to establish adjacency of a wetland. For example, where a wetland is physically separated from a tributary by a man-made levee and such artificial structure has a culvert connection through the levee, the culvert is visibly apparent and can be easily observed as potentially providing a direct hydrologic surface connection in a typical year. However, field observations may be time-intensive and certain determinations may require data that are not available on the project site. Additionally, an assessment should be conducted to determine whether field observations reflect typical year conditions. If inundation is observed during abnormally wet conditions, additional data sources may be necessary to supplement those field observations. Aerial photographs, models, and physical indicators will also be discussed in this presentation as additional potential lines of evidence for making jurisdictional decisions. Current and historic aerial photographs can be valuable tools for determining inundation by flooding from an A1 through 3 water to a lake, pond, impoundment, or wetland in a typical year. Aerial photographs can be examined to look for visible signs of inundation as well as the extent of inundation. They can also be a valuable tool to determining whether a lake, pond, or impoundment contributes surface water flow to a downstream jurisdictional water in a typical year. Aerial photographs may help detect natural barriers and artificial structures that could be used to establish whether a wetland is adjacent. Historic aerial photographs could be particularly useful if there's a question about whether a barrier is natural or artificial. Aerial photographs are an example of a point-in-time data source, and a typical year assessment should be conducted for each location and date being considered. As we discussed in the typical year webinar, the agencies will generally use the antecedent precipitation tool along with other available sources of information to make a typical year assessment. LiDAR and digital elevation model, or DEM data, provide a three-dimensional view of the landscape and show elevation differences in an area of interest, which can be used to help identify floodplains along tributaries in the A1 waters. These data sources may also help identify possible connections from jurisdictional waters to wetlands, lakes, ponds, and impoundments. It may be possible to use LiDAR and DEM to identify the extent to which floodwaters may cover an area at a given elevation or stage along a tributary. Such information may help in determining if an area is inundated by flooding from an A1 through 3 water in a typical year. Topographic maps may also be used to identify the presence of water features, potential inundation by flooding, and potential contributions of surface water flow downstream. USGS topographic maps use blue lines to represent rivers, streams, and canals with different symbols depicting the type of feature. Certain symbols may indicate a marsh or another wetland type is likely present, and the map may aid in identifying whether an area is inundated by flooding from a nearby A1 through 3 water in a typical year. While the USGS topographic maps identify streams in the United States, in many cases these maps may depict blue line streams where they do not exist, or vice versa, and the blue line streams indicated on the map may extend further than a channel actually extends on the ground, or vice versa. The National Hydrography Dataset, or NHD, is another data source that has similar utility and features as USGS topographic maps. The NHD indicates specific features within a watershed, including the hydrologic unit codes, or HUCs, and rivers, streams, canals and ditches, swamp and marshes, dams, and similar features. The NHD can provide information about water body presence, water body type, water body extent, stream flow, and flow direction. These data may be useful for determining the geographic position of features of interest, which serves as one line of evidence in determining if a lake, pond, impoundment, or wetland is likely to be inundated by flooding from a jurisdictional water in a typical year. The NHD may also indicate the potential for a lake, pond, or impoundment to contribute surface water flow to a downstream jurisdictional water in a typical year. As with existing topographic maps, the NHD does not identify all streams, and many streams, particularly small headwater streams, may be absent from the dataset. It's important to note that the NHD is not a regulatory dataset. Additionally, the NHD has certain known limitations, including the fact that the NHD at high resolution does not distinguish intermittent from ephemeral features in most parts of the country and may not accurately identify on-the-ground flow conditions. Information from the NHD should be used in conjunction with other remote tools and on-site assessments. The National Wetlands Inventory, or NWI, was established by the U.S. Fish and Wildlife Service to conduct a nationwide inventory of wetlands to provide information on the distribution and type of wetlands. The NWI can be a useful tool when identifying the potential presence of water features, including wetlands, tributaries, lakes, ponds, and impoundments. The NWI can be used as a screening tool to help determine prior to a site visit if wetlands are potentially located on site, and if such wetlands may meet the definition of adjacent, depending on their geographic location. Caution must be exercised when interpreting NWI data, since it typically has not been verified by field surveys, and therefore the digitally presented data may not accurately depict conditions on the ground. Like the NHD, the NWI is not a regulatory data set. Furthermore, the NWI uses the Corden definition of wetlands, which, as we discussed earlier, is different from the agency's regulatory definition of wetlands. The Natural Resources Conservation Service has developed nationwide soil survey maps that may provide evidence of drainage patterns. In addition, soil surveys may identify existing flooding or ponding regimes along soil type boundaries. This information may be useful for determining the presence of wetlands and their position on the landscape. The soil survey maps may also help determine whether a lake, pond, impoundment, or wetland is likely to be inundated by flooding from a jurisdictional water in a typical year. Stream gauge data are available from federal, state, or local agencies or other sources. Stream gauge data can provide information on the magnitude, duration, frequency, and timing of flows along a given stream, which can be used in making inundation determinations. Care should be taken to ensure that any stream gauge data used are reflective of the current hydrologic regime and typical year conditions. As we mentioned previously, the data sources included in this presentation are not exhaustive. Other information not addressed here may be available to assist in determining the jurisdictional status of lakes, ponds, impoundments, and wetlands. For example, information about artificial structures that separate wetlands from jurisdictional waters could include construction design plans, permitting data, state and local information, or levee or drainage district information. Information about impoundment releases to downstream waters in a typical year could include dam operation records and other state and local information. Other examples may include flood predictions provided by the USGS StreamStats tool, regional regression equations for stream flow or channel dimensions such as bankful regional curves, and hydrologic and hydraulic models. We would like to note, under the final rule, floodplain maps such as those produced by FEMA may be informative, but not all wetlands that fall within floodplains are jurisdictional. While some floodplain wetlands may be jurisdictional, for instance, if they are abutting a jurisdictional water, the agencies have not included a floodplain interval to determine adjacency in the final rule. Rather, wetlands must meet one of the criteria previously discussed. We have already covered some relevant remote data sources, models, and high-frequency data sources that may be useful for determining the jurisdictional status of lakes, ponds, impoundments, and wetlands. Now we'll discuss physical and visual indicators that could be useful for determining if inundation by flooding has occurred in a certain area. Some of these wetland hydrology indicators used in wetland delineations that may be applicable in determining whether a lake, pond, impoundment, or a jurisdictional water has been inundated by flooding from an A1 through 3 water. However, it is also important to determine whether such inundation occurs during a typical year. These indicators include, but are not limited to, watermarks, sediment deposits, drift deposits, and moss trim lines. I'll briefly discuss each of these indicators on the following slides. As you can see from these pictures, watermarks are discolorations or stains on the bark of woody vegetation, rocks, bridge piers, buildings, fences, or other fixed objects. Watermarks indicate a water level elevation and can be used to help determine the extent of flooding in lower elevation areas. Note that these watermarks may indicate a water level elevation, but are not indicative of the inundation frequency necessary to determine jurisdiction. Recall that inundation by flooding from a jurisdictional water must occur at least one time in a typical year. As evident in these pictures, sediment deposits leave visual marks on fixed objects like trees after surface water recedes. Sediment deposits are indicative of inundation over a long enough period to allow for suspended sediments to settle out. Typically, this would indicate a more recent inundation event, as the sediment deposits likely would not remain on the object for a long period of time after the surface water recedes. Drift deposits consist of debris that has been deposited on the ground or become entangled in vegetation or other fixed objects. Deposits consist of vegetation, man-made debris, or other waterborne materials. Drift material is often deposited at the high water line in ponded or flooded areas. Note that these drift deposits may indicate a water level elevation, but are not indicative of the inundation frequency necessary to determine jurisdiction, that is, at least one time in a typical year. The last physical indicator we'll discuss is moss trim lines. As you can see in these pictures, moss trim lines on trees or other upright objects are formed when water-intolerant mosses growing on tree trunks or other upright objects are killed by prolonged inundation. This forms an abrupt lower edge to the moss community at the high water level. Like the other physical indicators we have mentioned, note that these moss trim lines may indicate a water level elevation, but are not indicative of the typical year inundation frequency necessary to determine jurisdiction. This concludes our discussion of lakes, ponds, impoundments of jurisdictional waters, and adjacent wetlands. For more information about the Navigable Waters Protection Rule, the published Federal Register notice, and the supporting analyses and fact sheets, I encourage you to visit EPA's website listed on this slide. We will be posting the recording of this webinar on the website shortly. A recorded presentation providing an overview of the rule is available on EPA's YouTube channel, and questions can be sent to either the EPA's or Corps' email boxes. Thank you, and I will now turn it over to Owen.
Thanks, Mindy.